Welcome back. This is part 2 of the 2-part series of energy storage, sizing and sales. If you haven't seen part 1, get back and watch it. If not, sit back and enjoy part 2. Energy storage and solar sales process, customers existing solar. Have to select the storage now. We will select a lithium iron phosphate solution. We will design for 80% depth of discharge to maintain cycle life and warranty conditions. Generally, the warranty stipulates a certain charge or discharge rate and a certain depth of discharge. If you exceed those in any way, shape or form, read the fine print, because in a lot of cases your warranty gets altered. So instead of a 10-year warranty or 3,000 plus cycles, it may come down to a 4-year warranty. So we'll need 12 kilowatt hours divided by 0.8, which equals 15 kilowatt hours of total storage. But what if customer wants some kind of backup if the grid fails? And we can't predict when the grid fails, so the question is, how much energy buffer do we require? So we will need 14 kilowatt hours, 12 kilowatt hours for the loads and 2 kilowatt hours for backup. 14 kilowatt hours divided by 0.8 equals 17.5 kilowatt hours. Let's say we select a 48 volt system. So we will need a 364 amp hour bank at 48 volts. So we'll select a 400 amp hour system. 400 amp hours times 48 volts equals 19.2 kilowatt hours. Remember, with energy storage, you have this total capacity available in the battery. But you don't take everything out of the battery, you take a certain percentage out. And also, how quickly you're going to take it out as well. So you have to determine what kind of loads may be addressed by the batteries and what may not. Battery brand's largest cell is 200 amp hours at 12 volts in this particular case. So we will need to parallel and series to achieve 400 amp hours at 48 volts. We will need 4 by 200 amp hour cells in series parallel to another 4 by 200 amp hours in series. Total of 8 times 200 amp hour 12 volt cells. Let's say now that the battery brand's largest cell was 400 amp hours at 12 volts. Still need to series to achieve 400 amp hours at 48 volts, but we don't have to parallel. We will need 4 by 400 amp hour cells in series. Total of 4 by 400 amp hours at 12 volt cells. Obviously the 400 amp hour cells will be heavier to deal with compared to a 200 amp hour cell, and this is something to take in consideration when installing. So batteries come in a variety of sizes, and at the end of the day, the individual battery capacity, the individual cell size is really not that important. It's more the combined energy storage component of those cells, whether it's a series parallel configuration or you're just seriesing up the batteries. What about the existing solar? Assume customer has a 5 kilowatt system in Melbourne, Australia, and they have 10 kilowatt hours of loads outside solar production hours. During solar production hours, you have around 4 to 5 kilowatt hours of load. In wintertime, solar may not be enough. Rest of the year probably okay. Definitely fine during summer. Can system you have selected achieve tariff optimization? In other words, can you program the inverter to charge from the grid if advantageous? Is the discrepancy between tariffs enough to justify this functionality? With energy storage systems on the grid, there are 3 main factors: storage capacity, solar input contribution, grid input contribution. In addition, the inverter charger functionality and the ability to determine what input is used when, but this comes at a cost. With Standard Grid Connect, solar services the loads when it can. Cost savings at X dollars per kilowatt hour. No loads or loads fully serviced, excess goes to the grid, but at what value? Usually 9 cents per kilowatt hour. It's all about energy management or resource management strategies. The first question you ask your customer is, how did you find out about us? Was it the internet? Were you referred? Next question is, do you have an existing solar system? What are the roof details? Look at the roof on near maps or similar. What are the details of the existing system? Do you work away from home? What is your tariff arrangement? What is your average daily load? What percentage of energy is consumed during daylight hours compared to after dark? Is there a suitable garage or similar available to install the equipment in? Is grid disruption a problem in your area, and do you want battery backup? Can I send you out an authority to act document so I can collect the interval data from your retailer? Send out a preliminary costing to customer, and if the customer says yes, analyse the consumption data after receiving from retailer. Then organise a site visit. Design and then submit formal proposal. So you go through this systematic approach of asking these questions, getting their responses, and that allows you to get to the stage where you can fairly confidently offer them a preliminary costing, because you're not going to offer them a full-blown formal proposal. Conclusion: establish the customer's driver for energy storage, whether it's psychological, financial, or a bit of both. Determine the exact functionality of the system that is required. Send out preliminary costing based on average daily load in response to questions asked. If they want to go further, analyse data, site visit, and then present formal proposal. Thanks for watching part 2 of the 2-part series on energy storage, sizing and sales. If you haven't seen part 1, go back and watch that. If you have any questions, any inquiries, any answers, please feel free to drop us a line and hit that subscription button if you see fit.